All right, let's talk Mars. All right, I got a picture up here of Mars. It's I had to shrink. I sized it badly, but that's Mars right there. It's all its glory. First feature it probably does is obviously the United States of America is on there. That's not it. That's not really there. We drew that on there to get perspective size. Mars is smaller than we are, about half our radius, right? So it gives you 1/8 of our volume. Its surface density is such that it's actually less than ours. It's about 4. So because of that, it probably has a smaller core, and gravity is quite a bit less there. It's like 1/3 of what it would be on Earth, so you could become a superhuman. The other thing you should notice from this nice picture is something called the Valley Marinaris, which is a really large valley that covers most of one side of the planet. Pretty good sized planet. It's way bigger than the Grand Canyon. The Grand Canyon would be, think about the Grand Canyon on this scale. Grand Canyon would be about, what, this size? Okay, so yeah, not even close. Also, by the way, Mars has the largest volcano in the solar system. It has something called Olympus Mons. That, by the way, that's Valley Marinaris. But Olympus Mons, the largest volcano, that volcano is so big, yeah, our biggest volcano is basically the island of Hawaii, and that island of Hawaii would be like 1/100th the size of Olympus Mons. So, what else do you need to know about Mars? Mars' day is a little bit longer than ours, 24 hours and 30-something minutes. Its temperature on the cold side is about negative 190 degrees. On the warm side, it's positive 86 degrees. That's not bad, but the average is negative 81 degrees Fahrenheit, which is cold. Why is it so cold? Well, the first thing I'd say is this. The atmosphere's carbon dioxide. Well, global warming. But it's very, very thin. Extraordinarily thin. So therefore, that's not the answer to the question. Turns out it has a very thin atmosphere, so therefore it doesn't get warm, so therefore it is going to get cold on one side, and during the day side it gets warm. It's farther from the sun, so it's warmer, as it as warm as it could possibly be. But it turns fast enough that it keeps itself moderately warm. It has things like dust storms and things like that, but its atmosphere is so thin you need to imagine that if you were a human being and you walked out with a spacesuit, your body would start to puff up like a balloon and would eventually pop. And that's kind of gross. And so that would be there. Almost no oxygen to breathe. Almost no water on the planet, which is a very interesting puzzle for us to deal with. But anyway, I've so far got it. It turns the same direction we do. It has 2 moons. They're extraordinarily small. In fact, they're so small, we really think they're just asteroids that happen to wander in its neighborhood. And so therefore, we call them moons because we go around Mars as long as we've been looking at Mars, but they're for the most part really, really small. In fact, one of them is so small that if you jumped off the surface, you could, if you had an Olympic level perfect jump, somehow with your spacesuit on, you could jump off of it and land on Mars. I wouldn't recommend it because you would burn up. The atmosphere is thick enough, you would burn up on your entry. Now, have we been to the surface? Human beings haven't been to the surface, but we have had many probes land on the surface. The first one of those is my favorite because it's an oldie but a goodie. See if I can find it. I don't have it. Oh, there it is. This is what happened when Viking landed on the planet. Viking landed on the planet. It was an extraordinarily expensive device in the 1970s to figure out where we're going to land on Mars. Now, keep in mind, this is part of the space race at the time. The Russians were threatening us with landing on Venus before we get there. So we said, well, fine, we'll go to Mars and beat you there. And turned out that was a good move because Mars is land-onable and Venus is not. Now, there is a bad news. It takes 9 months to get to Mars on what's called free return orbit, which means pretty much that's how long it's going to take to get there on most rockets, unless you want to burn a lot of extra fuel. So because of that, it's a 9-month trip. 9-month trip there, 9-month trip that. Low gravity. Human beings aren't well designed for that. That's theoretically why we haven't gone there yet. Again, once you get there, it's a pretty hostile place to live. Now, you look at that front window, you're like, and there's not really a window. This is actually just a camera mounted on the top. You see that, and it looks pretty much like Nevada, at least the part that's down the hill, not the part that's up pretty by the lake. Now, it is pretty much like Nevada. That's true. Except when we went to test it, we thought, well, maybe we'll find life there. We got all excited. We did a bunch of experiments, put water in the dirt, softened and grew. We smashed it up and saw how much carbon was in there. We tried all sorts of experiments. We did, I think it was 13 experiments, and all 13 said, no, no life. So everyone went sad, everyone went home, and nobody landed on Mars for a while because, you know, what's the point? It's just a big, dumb rock. And we're no longer racing with the Russians, so getting there first doesn't really matter anymore, so we don't care. As time wore on, there was something puzzling. And puzzling has to do with, back to this, where are the craters? Thin atmosphere, where's my craters? Remember, if you don't have an atmosphere, you're going to get pummeled. You're going to look like Mercury. It's got a thin enough atmosphere, it should look like Mercury. On top of that, it can't have many, it's got a couple dust storms, but not enough to get rid of all that craterage. Where is that? It's worse than that. It's spookier than that. Let me give you spookier than that right now. Boom. This is what the surface of Mars looks like when you have a better camera than the one they had in the 1970s. This is actually a little cute little probe that drives around the surface of Mars, taking little pretty pictures. And it looks even more like Nevada. Well, what's frightening about this picture is this. Right in the middle here, right in this zone right here. See that zone right there? If you saw that on Earth, you would say that was a washout from water. Uh-oh. Also, these little probes that are driving around, they're drilling holes in things. One of the things they're drilling holes in is something called breccia and conglomerate. These are rocks, if you find on planet Earth, they were made by, you guessed it, water. They're very old rocks. It appears that at one time, Mars may have had water. Not just a little bit of it, but a lot. Enough to have river valleys, floods. Could even be possible that Mars had 20% of its surface covered with water. What happened? Lack of atmosphere, lack of gravity, that water would have eventually escaped. And slowly but surely Mars became lifeless. Now, the question is, did it ever have life to begin with? Now, that's an interesting question, too, because we found zero proof of it, with one notable exception, which is truly disturbing, which we'll get to in a moment. There's no indication there's life there. Our digging around, trying to find any hints of it, have failed. In fact, the surface of Mars is so waterless that you pretty much can't detect any molecules of water at all. But there are, near the two poles, up in this region here, and then the bottom region down below, there is a permanent layer of ice we've discovered by taking really careful pictures that is wedged underneath the surface. It's hiding underneath the surface. That's where it's trapped. And at nighttime, it comes out, briefly swirls out there as a kind of a mist, like a dew, and then it sinks back into the ground, and that's where it's keeping its water. So it does have some interesting features that are now we're spending more time discovering. Now, about the craters. At one time, Mars probably had a significant atmosphere, probably had weathering like we have here. That is all gone now. So whatever happened to Mars, it happened billions of years ago. In fact, rocks on the surface appear to have that strange number again, 4.2 billion years ago, 4.1 billion years ago. Sound familiar? How old is our solar system? About 4.6 billion years ago. So what else can we deduce from this? Well, there's one. If you like funny, weird stories that make you bother to stay up late at night, here is something weird for you to think about. In Antarctica, we discovered rocks that had the same chemical makeup as Mars. Apparently, during these collisions about a million years ago, or a billion? Billion years. No, million years. That's a million years ago. I don't know. You have to take one of those two numbers. God, it feels like it's older than that. Maybe 100 million years? 100 million years ago. 100 million years ago is about right. Okay? There were rocks that were blown off the surface of Mars and landed on our polar ice caps. And so, as you know, we've been punching holes in our solar ice caps to protect them from melting. Yeah, somebody ought to think about that really hard. But even, you know, when you poke a hole in ice, it melts faster. But whatever. They're drilling holes in the ice to find out what happened in the distant past. One of these ice cores they dug up, they discovered rocks that got buried in the ice. Now, one of these rocks, several of these rocks were clearly marked as coming from Mars. We thought, oh, they came from Mars. One of those rocks had little holes in it called vesicles. It meant holes in the inside of it, which was really interesting because those holes If we found it on planet Earth, we would say this was a bacteria infestation. Well, this rock was sealed. So it came from Mars, melted on the outside. Those holes were there when it left Mars. Now, there's a couple ways you can defeat this. One, you say, well, we're just wrong. Maybe they got broken up and some animal lived in there and it resealed itself up. You can argue that so what, it has holes. There might be some other way that could happen on Mars. It's not a big deal. Maybe it didn't come from Mars to begin with. It has a similar chemical structure. Why you get excited we found it on planet Earth in our backyard. It is not necessarily proof of life. But it is very interesting because these rock formations that we're discovering vary to as late as 500 million years ago. What if you don't know is that hopefully about 500 million years ago, life suddenly exploded on this planet. We went from single-celled organisms that sometimes clumped up into 2s and 3s and 4s, little-celled organisms, to a vast variety of animals all over the planet in a very short period of time. So there is some question. So if you really like those conspiracy theories, here's a great one for you. Life did not start on Earth. It started on Mars, and it came flying on asteroids that were blown off the surface of Mars as it was getting extinct. A lot of problems with that theory, and a lot of proof needs to be filled in. That's kind of fun to talk about. What you need to know is that Mars at one time did have an atmosphere. It did have possibly had rain. It possibly had valleys and oceans, and that slowly was bled off with time. So yes, that is where Earth is going, but we're a long ways from it. Okay. All right. So now you know. Mars turns slower than we do. It turns the same direction we do. It goes around the sun the same way we do. It's about 9 months away, so it's a longer trip away than Venus would be, so it's much farther out there. Its temperature variation is larger because it has a thinner atmosphere. All those things are true about Mars. And that's what we need to talk about with Mars moving forward.